right, guess what I'm going to ask you to do? Did you say look at another argument? Here it is. If it's snowing, then the mail will be late. The mail's not late. Therefore, it's not snowing. So here's my question to you. Let's just assume that it's true that if it's snowing, then the mail will be late. And let's also assume it's true that the mail's not late. Does that mean it has to be true that it's not snowing? Is there any way that it could be snowing? If it's true that if it is snowing, then the mail will be late, and if it's also true that the mail is not late. And the answer to that seems to be no. Because if it's true that if it's snowing, then the mail will be late, and the mail's not late, then it can't possibly be snowing. Because the first premise says if it is snowing, then the mail will be late. And the second premise asserts that the mail's not late. So it seems like this conclusion follows with logical necessity from these two premises being true. And the question for us again is, well, why is that? And we can answer that question by looking really carefully at what's going on in this argument. We have this statement, the mail will be late, appearing 2 times, but a bit differently. In the first premise, the statement says the mail will be late. And in the second premise, we have the negation of that statement. The mail is not late, okay? So we think back to our relationship between sufficient and necessary conditions, and we recognize that what appears on the right-hand side of the horseshoe, what we would call the consequent, is a necessary but not sufficient condition to imply the left-hand side of the horseshoe. Okay, what that means is that in order for the left-hand side, the statement on the left-hand side of the horseshoe to be true, and has to be true. The necessary condition has to be true. The condition on the right-hand side of the horseshoe has to be true. If you look at your truth table for conditional statements, you'll see that on line 2, what appears on the left-hand side of the horseshoe is true. What appears on the right-hand side of the horseshoe is false, and the horseshoe is false. So in order for the left-hand side of the horseshoe to be a true statement, the right-hand side of the horseshoe is a true statement. And what the second premise here is asserting is that what appears on the right-hand side of the horseshoe in the first premise is not true. Because if it's true that the mail is not late, then it has to be false that the mail will be late. Okay? And if it's a necessary condition that the mail being late, that the mail be late in order for it to be snowing, then the conclusion statement has to follow. If the mail's not late, then it can't possibly be snowing because it's necessary for the mail to be late when it is snowing. Okay? So what we have here is another valid form of argument called Modus Tollens, the denying mode. Any form of argument that's a Modus Tollens is a valid argument. And we look to see what's happening in this argument. One of the premises is going to deny that the consequent, what appears on the right-hand side of the horseshoe in the other premise, is true. It's going to be its negation, or it's going to deny that whatever appears here on the right-hand side of the horseshoe is true. Therefore, telling us that what appears on the left-hand side of the horseshoe is also not true. And just like with our other argument forms, it doesn't matter what the order of the premises is. We can have the denying statement appear first above our conditional statement, or more traditionally, we can have the conditional statement appear on top of the statement that does the denying. What matters most here is what's happening in the argument. We have the consequent of the conditional statement being denied or negated by another premise.